Mostly in data engineering domain, what a data engineer do, he will ingest the data from some sources, whether that is the on-premises sources or some cloud sources. So they will first ingest the data, okay, and then they will store that data in some of the storage system, okay. So and then once the data is stored, so what they will do, they will process and analyze those data, and then they will create some report on top of those data. So they can create any Power BI report or any ClickView report. So that report they will create. So this is how a data engineering project life cycle looks like. It's not like all the data engineering projects are like this. In some data engineering project, you will see on the at the end point. So instead of visualizing report, so might be the data will be shared with some data scientist team, or will be shared with some blockchain team. So it is just one of the way how a data engineering pipeline looks like, but this is not the only way, okay. So I can say this is not the only architecture, but this is one of the architecture. Like you will ingest the data, and then you will store the data in some of the storage system, and then you'll process those data. You'll do some transformation on top of those data, and finally you will visualize those data. Okay. So let's understand, since we are going to study about the Google Cloud, so we need to understand like what are the storage system, or what are the data processing services are available in Google Cloud. Okay. If any of you are familiar with, any of you is familiar with the Google Cloud, so they might be knowing for storing the data. So let's say there are two types of data. Okay, we know like mainly there are two types of data, like not data, like mainly there are two types of data processing. Like we can process the data in a batch manner, or we can process the data in a streaming manner. Okay, so we'll understand how what is the difference between batch and streaming. But here let's understand what are the ingestion system available in the Google Cloud services. So when you are dealing with the batch data, when you are ingesting your data in different batches, so in that case you can use all these storage system of the Google Cloud, like cloud storage transfer service, BigQuery data transfer service, and transfer appliances. So these are the services of the Google Cloud. And guys, try to remember all these services, because if you are going to attend for certification, they will ask you what are the ingestion services, data ingestion services for batch processing are available in the Google Cloud services. So try to remember all these like services name. And then for the streaming data, in order to process the streaming data, so we know that in our on-premises we have Kafka system, where we can ingest streaming data, we can process streaming data. So similarly, in Google Cloud we have something called PubSub, which is nothing but publisher and subscriber. So publisher will publish the message, and subscriber will subscribe to that publisher to get that message. So PubSub is one of the services of the Google Cloud, which we use in order to do the streaming processing. Similarly, when you are ingesting some of the application data, so in that case, we are going to use all these services. Application data means, let's say you are running some application on the front end, and it's generating some logs. So in order to process that log, we have called logging services in the Google Cloud. Similarly, there are other services as well, like Cloud SQL, which is used to process the SQL data. And similarly, Bigtable is there, which is used to process the NoSQL data. So we are going to study in detail. We are going to study all of these services in detail in our coming classes. Okay. Next comes to storage. So first was data ingestion. We ingested the data, we store somewhere, let's say in cloud storage or in cloud SQL table. So first was the ingestion of the data, and the next phase is the storage of the data. So we know that if you have any idea on the data domain, you know that data is uh, broadly classified into three categories. So we have structured data, we know semi-structured data, we have unstructured data. I actually wanted to write here something, but I don't know how to use the whiteboard here in Skype. Not getting that option here. Okay. So structured data is structured data will be, like it will be in the form of rows and columns. So it will have a particular structure to the data, like it will have a tabular structure, it will have rows and columns. So that is called a structured data. And the structured data is also classified into transactional data. So we know like the structured data we have OLTP and OLAP, like online transaction processing and online analytical processing. So in order to process online like transactional data, so we have called Cloud SQL and Cloud Spanner. So there is a little bit difference between this Cloud SQL and this Cloud Spanner. So we'll understand that when we'll study all these services in detail. But for now, just remember that in order to store the structured data, and if it is transactional data, you need to use either Cloud SQL or Cloud Spanner. But when we go for Cloud SQL, when we go for Cloud Spanner, we'll understand that once we start studying, once we'll go through each of these services. And next is the analytical data. So analytical data is like mainly used for data warehousing purposes. So we have some service in GCP called as BigQuery, which is used for to store analytical data and also to process the analytical data. So you can store the data, you can create a table in BigQuery. Also, you can do the processing, like you can write SQL query or you can write JavaScript query as well. So in order to process those analytical data. And next is semi-structured data. So semi-structured data, guys, if you have seen any JSON file, so that is how semi-structured data looks like. And we have two types of semi-structured data. We'll have fully indexed semi-structured data and row key type of row key indexed semi-structured data. So if it is fully indexed, we will use cloud data store in order to store fully indexed semi-structured data. And in order to store row key indexed semi-structured data, we are going to use cloud bigtable. So cloud bigtable again is a petabyte scale. You can store minimum 1 TB. If your data volume is minimum 1 TB, then only you should go for cloud bigtable. And don't worry, we'll also understand when we should go with cloud store, cloud data store, and when we should go with cloud bigtable. So that we'll understand in our coming classes. For now, just understand for semi-structured data, we have two services, Cloud Data Store and Cloud Bigtable. If it is row key indexed, we need to use Cloud Bigtable. If it is fully indexed, we need to use Cloud Data Store. And next is coming to the cloud unstructured data. So unstructured data means if all your audio data, video data, picture, so all these are unstructured data. So for unstructured data, we have cloud storage. So we'll store all the unstructured data in cloud storage, and it's a very low cost storage, guys. So cloud storage compared to other storage like Cloud Spanner, Cloud SQL, you can store same volume of data in cloud storage with less cost. So just remember that. And next is, so we cover data ingestion, then we cover storage. Now is the processing and analysis of the data. So we have already stored the data in one of our system, in one of our, let's say, cloud SQL or cloud storage, and then with next phase is we need to process that data. Or if we are not going to process and analyze, what is the point of just storing the data, right? So we need to process that data, and we need to understand what are the services of the Google Cloud are there to process and analyze the data. So we have something called Cloud Data Proc. If any of you have worked on Spark, Hive, HDFS system, so Cloud Data Proc is same as the Spark and Hadoop application. So here you can create like Spark and Hive cluster, and you can store your data. You can not store, you can process your data. And next one is your, yeah, next one is your cloud data flow. So cloud data flow is used like it's also used for data processing. So the difference between cloud data flow and cloud data proc is, so when you are creating a cluster in cloud data flow, you need to manage the number of nodes, how many driver node, worker node, all those things you need to manage. But in case of if you don't want to worry about like scalability, then at that point you should go for cloud data flow. Okay, so cloud data flow is a fully managed and no operations services. You don't need to worry about when you need to scale your cluster, when you need to scale down your cluster. You don't need to worry about that. You just need to process your data. You just need to focus on the data processing. So in that case, you should go for data flow. But if you can manage your cluster, if you want to manage your cluster, number of nodes you want to create, in that case you can go for the cloud data flow. And next one is cloud data prep. So cloud data prep is completely UI driven. So if you have seen in Google the data sheets, or it's like cloud data prep looks like almost, not almost, but like similar to, it looks like up to some extent it looks like Excel file. Okay, so cloud data prep. So there what you can do, if there are smaller transformation you want to do data, let's say you want to apply filter on some of the column, you want to remove null values, if you want to remove any column from your data set. So all those things you can do on the cloud data plane. And again, it's fully managed, it's no operation. Like, so when I am saying like it's fully managed and no ops, just understand that you just need to focus on the data processing part. You don't need to worry about how to create a cluster, how many nodes you need to put on your cluster, what should be your cluster configuration, whether you should scale up your cluster or not, how the cluster scaling will happen. So all those things you don't need to worry about that. So when you are using cloud data flow and data prop, so these are fully managed by Google. So you don't need to worry about any of these cluster configuration. You just need to worry about your data processing part. But in case of data prop, you need to handle everything. Okay, so that's the difference. Next is we have processed our data and we have analyzed our data. So the last phase is, as I said, guys, don't assume that this is the only way a data engineer works or data pipeline looks like. There are many different structure of the data pipeline. Okay, so this is one of the structure I can say. So when you are going to visualize your data, so there are multiple services in Google's cloud available. So one of them is Google Cloud Data Studio. So where you can, it's like a BI engine. So like in Data Studio, if you have used Tableau or Power BI, so the Google Cloud Data Studio is like that. So where you can create dashboard, you can create visualization in Google Cloud Data Studio. And next one is Data Lab. So Data Lab is if you have used Jupyter Notebook. So Data Lab is nothing but it's an interactive Jupyter Notebook. It supports all the data science library which are there in Python or in other languages. So it supports all of them. It's just an interactive Jupyter Notebook. And next one is like there are some pre-built APIs also available in Google Cloud Services. So like Vision API and Speech API. So these are used for machine learning model building. So till now we covered all the major steps what are there in a data engineering pipeline. Any doubts, guys? Any doubt?
When to use which service? Who will be guiding us on this?
Sorry.
When to use which service? Who will be telling on this? Architect will
I'll
be.
be telling you. I'll be telling. I already told you up to some. I already told you some of the points, like when you need to go for Google Cloud SQL, or when you need to not go for Google Cloud Data Proc, when you need to go for Google Cloud Data Flow. I will tell you in detail. For now, just understand these are the services we are going to use if you are doing data processing. These are the services we are going to use if we are doing data storage. Just understand that up to that extent. Okay, I'll tell you if your data is like this, which services you need to choose. Okay, don't worry about that. I'll tell you. Any other doubt, or shall I move?
Yeah, I can continue.
And let's understand. See, there are what are if I say what are the types of data processing techniques are there. So, as I said, mainly we can categorize the data processing techniques into two categories. So one will be our batch processing, and the other one will be streaming processing. So in case of batch processing, what happens? We have defined start and end time. So there will be a different defined window. So let's say you are going to process your data on a daily basis or weekly basis or a monthly basis. Let's say you have your electricity bill or your telephone bill. So these are going through batch processing because all the bills are getting generated on a monthly basis. So these are all the processing is happening on a batch mode. So we have a defined start and end time for that, and also we know the data size as well. So mostly in case of batch processing, what happens? See, if you are going to process a weekly data, or if you are going to process the data on a monthly basis, definitely the volume of the data will be huge. So in batch mode, we are going to process large volume of the data, and of course it's a legacy system. We almost know the data size and the finite. Okay, and the example, if you see the payroll system or the billing system, the salary which we are getting at the end of the month, all the processing is happening on a batch mode. So that's the batch processing. Even if you are if once you join any data engineering project, uh, some of you might not get any opportunity to work on the streaming data, to process the streaming data, because many projects will be there where only the batch processing is happening of the data. Also, some of you might get opportunity, or some of you might join project where the streaming processing is also happening. Okay, so accordingly you will have to choose the services. If I talk about the Google Cloud, so on the batch processing, we just saw that for the batch processing we need to use Cloud SQL, Cloud Storage. So these are the services we need to use. For streaming processing, we have PubSub, which is similar to Kafka. So PubSub is nothing but publisher and subscriber. Okay. Again, in case of streaming processing, where data will be flowing continuously. Okay, there will not be any bound on the time or start time or end time. So the data will be processed as it arrives, and the size of the data also we don't know. We can define the window size, or we can define the micro batches of the size, but again the data the total how much data we are processing, so that we don't know. And if I talk about some of the example, you can say stock market data. So if you have any knowledge on the trading, if any of you are into trading, so you know, like all the stock market processing happens on every day. Okay, so and also the e-commerce transaction or the social media data. So these are the streaming data. So whenever you once you post anything on the social media, once you upload a picture on the social media, it will be shown to all your friends, or all of you who are there on the social media. Everybody can see that. So there the data processing happens in a streaming manner. And next, let's understand another important concept which is related to the data engineering, and that is OLTP and OLAP. Okay, so OLTP is like the it stands for online transaction processing. So OLTP it's a again it's a legacy system. So OLTP is like if you are going to store your data on a row based, and if you are going to insert and update your data on a row based, means you are going to insert data on a row wise and you are going to update your data on row wise, so that is known as OLTP. Okay, so in case of OLTP, so all the tables are highly normalized. When I say highly normalized, so if you say like if there is a table, sales table, and if I want to highly, if, let's say there are many data redundancy are there in the sales table. Okay, so data redundancy, I hope all of you understand what is the meaning of data redundancy. Data redundancy means there are many duplicate records are there on the sales table. Okay, so when you are going to normalize the sales table, what you will do, instead of one sales table, you will create many tables. Like you will create a customer table, you will create order table, you will create order item tables. So that is known as normalization of the table. So in case of OLTP, what we will do, we normalize the table, okay, for the transactional processing. And the OLTP is highly integrated. So it is highly integrated. So highly integrated means, so if you are like, so in case of OLTP, what will happen? Like if you are, so there are multiple databases. Okay, so we are extracting the data from of various databases, and we are storing the data in one of the databases. So that is known as highly integrated. And OLTP is mainly used to modify your databases. Like the databases, if there is a new record comes, you can store the data, you can update a row, or you can insert one row. So mainly the OLTP is used to modify the databases. So that is the main purpose of the OLTP processing. And as I said, it minimizes the data redundancy. So data redundancy means if there are any duplicate data on a table, so just remember, in order to reduce the data redundancy, you need to normalize your table. Normalize means if there is a sales table where in one sales table you have customer data, you have orders data, you have order items data. So if you are going to normalize that table, instead of one table, you will create three different tables. One will be for customer, and that customer will have only customer data. One will be for orders, and that order table will have only order data. And there will be one table for order items. Obviously, you will create like common key in between these three tables in order to extract any information. But instead of one table, earlier there was only one sales table, and now after normalizing, so you will create three different tables, so that the data redundancy will reduce, means the duplicate data will not be there on the table. And also, like if you know, like acid compliant, acid means atomicity, consistency, isolation, and durability. So all the Wells TP systems are acid compliance. Okay, let's go to OLAP. So OLAP is online analytical processing. So OLAP nowadays we are using uh, to like to process the big data, and to whenever you are creating some data warehouse or business intelligence tool, you will go for online transactional processing. Okay, and online transactional processing is used mainly not to modify your database, it's mainly used to query your databases. Okay, and in OLAP what we'll do, we'll query a low volume of the data. Okay, so that is all about OLAP. You can see like some of the tools which we are using nowadays for OLAP processing, like there is Google BigQuery, and then in Amazon we have Amazon Redshift, then we have PostgreSQL, then we have Snowflake and Firebolt. So all of these we are using for OLAP processing. Any doubts till now in between OLTP, OLAP?
No, sir.
Okay. So now let's understand the difference between SQL and no SQL. So no SQL means it's not only SQL. So whenever you will process your data, you'll see that in case of SQL, so what happens in SQL, we have a fixed structure of the data. We have rows and columns in case of SQL, but in case of no SQL, we don't have a defined structure of the data. So mainly when you are dealing with structured data, we use SQL, and where we use like in case of SQL, we use gigabyte or terabyte volume of the data. But when you are dealing with when you are doing no SQL processing, so in that case we are using terabyte and petabyte volume of the data, like we are handling high velocity of the data. And also, as we discussed earlier, so SQL tables are mainly used in case of OLTP processing, so where all the tables are normalized. And in case of no SQL, so we use to query data warehouse, so where all the data will be stored in one warehouse, so that will be in case that will be in denormalized form. Okay. And also, like if you have any database, if you have worked on any of the databases like db2 or any other databases, so that database in those database we use SQL query. So in order to scale those databases, we need to upgrade our hardware, and that is known as vertical scaling. Whereas in case of no SQL, if you have used Cassandra or MongoDB, so in that case, what we need to do, we need to create a partitioning on some of the columns of the data set, so that we can do a horizontal scaling of the data. So that these are the main difference between SQL and no SQL. And next, let's understand what is data warehouse and data lake. Okay, so data warehouse, uh, so you can say it's not same as databases, so data warehouse, but it stores the copy of the OLTP database. Okay, it stores data from other sources, like from IoT sources or analytics sources or any metadata information it stores. So it will have a structure in case of the data warehouse. Okay, and it will collect and aggregate data from the many sources, as I said. Okay, so data warehouse, if you see example, let's say if you are doing some kind of social processing some social media data, so they will have a social media warehouse. Similarly, if you are working in case of some banking project like HSBC or Bank of America, so they'll have a banking warehouse, like where you can like analyze the spending pattern of each customer using their data warehouse data. Also, like if you are working on any government on data, so they will have some data warehouse. So I am just telling some of the examples, like they will have some of the data warehouse in government data, so where you can use their data which is there on the data warehouse to analyze some tax fraud and analyze some tax payments and all. So if I talk about the characteristics of the data warehouse, so it mainly it is subject oriented. So what I mean by subject oriented is, so when you are creating and designing any data warehouse, you need to focus on a specific subject. Let's say if you are creating a data warehouse, whether that is for a customer or marketing or sales, so you need to focus on a particular area, so that is known as subject oriented. And then next one is your data warehouse should be integrated. So integrated means, as I said, when you are ingesting the data into your data warehouse, you'll ingest the data from various sources, from IoT sources, from analytical sources, from on-premises data from the other cloud services. So you will ingest the data to your data warehouse. So from various sources. So that's why it is called integrated. And next one is non-volatile. So non-volatile means, so when you are storing the data in your data warehouse, so that data is going to be stored for permanently. Okay, you are not going to delete that data. So whenever you are storing the data in data warehouse, mostly data will be stored in a read-only mode. You are going to just read the data, and data is permanent. It does not get deleted. Okay, it just keeps growing and all. Okay, all the operations like delete, update, and insert, all these operations are omitted in case of the data warehouse. So for example, let's say let's understand the data lake first. So in case of data lake, what will happen? So you will just store the raw data. You store unstructured data. You don't. So but when you are storing the data in data warehouse, you need to filter all the null values or filter out all the unnecessary data when you are storing the data into a data warehouse, because as I said, data warehouse is very subject oriented. Let's say you are creating a data warehouse for marketing purposes, then in that data warehouse you are going to store only marketing data. You cannot store any other data or financial data. So you need to remove or you need to filter out all the financial data. So you can imagine, so a lake is as a you can imagine like lake is similar to a sea where all the like salty water are there. But in case of data warehouse, what will happen, you will filter that salty water, you will get only the fresh water, and you will store that only those fresh water. Okay, so that we can consume that data. So data warehouse means if you are storing some data on the data warehouse, you can, anybody can go and consume that data. Okay, but if you are storing the data in data lake, it's all raw data, it's all unstructured data. You can analyze the data, but you cannot consume the data. I consume means you cannot derive any information from the data. You cannot derive any business decision from that data if you analyze the data lake data. Okay, so that's the difference between the data lake and the data warehouse. Also, as I said, it's a low cost storage because we are going to store all raw data and unstructured data. We mainly, if you are going to work in any kind of data engineering project, you will see like there will be two-layer architecture or three-layer architecture in case of the data engineering project. Mostly it will be three layers. So one will be your data lake layer, another one will be your staging layer, and then it will be your data warehouse layer. In some of the project, data mat layer is there, but again, like you will not see data mat layer in many projects as well. And after data mat layer, then the top layer is the BI tools where you are going to visualize the data. Okay, so this is called as three-tier warehouse architecture. Okay, any doubts till now? Any questions?
No, no.
Okay.
So when you go for data lake,
No, see, there is no option that you will go for data warehouse without having a data lake. Okay. So first of all, you'll have to, let's say your data is on, as you can see here. See, my data is there on the IoT data. So I have data on some on-premises system. I have data on my MySQL databases. So what I am doing, I'm ingesting all the data. I am ingesting the data from all of these sources into the data lake first. Okay, and then what I am doing, I'm cleaning the data using some like BigQuery or any other tool or any other GCP services. I'm cleaning those data, and after cleaning the data, we are going to store the data either in staging layer or in the data warehouse layer. Okay, so that it's not like you will go for data warehouse and you will go for data lake. See, data lake and data warehouse both are built for different purposes, and if you are going to work in any data engineering project, you will find all both both the structure in your data warehouse architecture. So that's why it is called as three-tier architecture. So three-tier means on the bottom layer we have data lake and staging layer. In the mid tier we have data warehouse and data mart, and on the top tier we have all the BI tools. So both of these data lake and data warehouse will be there on the project. Okay, and they are for different purposes. So firstly, you will have to ingest all the data from various sources. You will have to store it on the data lake, and from the data lake, you need to apply some transformation using BigQuery, using SQL, or using Python, PySpark, or any other services. You need to clean the data, you need to filter out all the unnecessary data, and then you need to put your clean data, transform data into the data warehouse. Okay, so data warehouse is built, anybody, let's say data scientist team or any other guy can come and extract the data from the data warehouse, and they can make some business decision. Okay, once they analyze the data from the data warehouse, they can make some business decisions. Okay, but from the data lake you will see all kinds of data. Okay, it's not cleaned, it's not transformed data. If you analyze the data from the data lake, that's the difference between the data lake and the data warehouse. So is it clear?
Yes, yes. It's same as Azure data lake, right? Then too. Sorry.
Correct. Yeah. Yes. So good point. So it's same as ADLS. Okay, ADLS Gen 2 or blob storage. It's same as that. And from ADLS, what we do? We have ADF. We have Databricks. So what we'll do? We'll extract the data. Okay, we can use either ADF or we can use a Databricks to extract the data from ADLS. So so where we can do some transformation. Okay, and finally we are going to store the data in either in Azure SQL or in let's say in some of the Azure Synapse databases. So similarly here we can use either BigQuery. So it's not hard and fast like we are going to use BigQuery. So instead of BigQuery also you can use Dataproc or Dataflow. Any GCP services you can use where you can do data processing and data analysis. So once your data is clear and data is transformed, once your data is clean, you can store the data in the data warehouse. Okay, so data lake, the cloud storage or data lake. See, data lake is a concept. Data lake is not name of any service, GCP services. It's a concept. It's there in all the cloud services. It's there in GCP, it's there in AWS, it's there in Azure. Okay, but the service name is cloud storage data lake. Okay, so I can also store my, I can also make my BigQuery as my data lake. There is no issue with that. Okay, but since we are just storing the raw data and unstructured data, so for low cost we can go for the cloud storage. Similarly, like Azure also, we have if you are storing the data in ADLS, cost will be comparatively lower, right? So those are the difference between data lake and data warehouse. And if I talk about data mart, so that data mart, it's a subset of the data warehouse. So it will get the data from the data warehouse, but it is designed for a particular department. Okay, let's say in case of marketing. Okay, we have in the data warehouse we have all the marketing data. Okay, in marketing also there are different departments. Let's say there is retail marketing, or there is so let's say there are different types of items we are marketing. Okay, that let's say we can say like uh, let's say some different kinds of products. Let's say the sometimes hair products, or let's say something like which product, any other products you can say. Okay, to target a particular type of customer, we need to create another layer which is known as data mart layer. Okay, so it will be a subset of the data warehouse layer, but it's not like you'll see data mart layer in all the projects. So there will be data mart layer in some projects. Data mart layer might be there, but it all depends on the business requirement. If business wants to create a data mart layer, if their data scientist wants to have a data mart layer, so that they can pull more specific data, then you can create a data mart layer, or else you can just create only the data warehouse. Okay, let's move on to the next slide. So let's understand the difference between ELT and ETL. So ETL is extract, transform and load, whereas ELT is extract and then we'll load and then we'll transform the data. So ETL we mainly use in case of small and medium volume of the data, whereas in case of large volume we need to load the data first, because if you go for transformation it will take lot of time. So we'll load the data first and then we'll do the transformation. So you can see that in case of ELT we have faster loading but the slower analysis time, because we are going to analyze huge volume of the data. So that's why it will take time to analyze the data. But whereas in case of ETL, it will take less time, like it will have slower loading time because we need to transform our data. So there it will take some time. Once the data is transformed, then only we can load the data. So transformation, in case of ETL, so it happens outside of the data warehouse. So outside of the data warehouse means here you can see here we are transforming the data first, then we are loading the data into the data warehouse. Okay, so that's why the transformation here is happening outside of the data warehouse in case of ETL. Whereas ELT, what we'll do, we'll load the data into the data warehouse first and then we'll do the transformation. Okay. Okay. So any doubts till now?
So how we define like this amount of data is large or this amount of data is medium? There is any like up to 100 MB or 1000 MB. Or,
Yeah, see, there is no such predefined size like this much data. If the data volume is this GB or this TB, then it's large or this TB. So there is no such predefined size. But mainly you need to understand the concept. Like if it is, if your data volume are in petabyte level, then you should go for the large volume data. You need to understand, like
okay,
whether if my requirement is to go for load the data first and transform the data. It all depends on the project, like project requirement. Okay, so let's say client wants to transform the data first and then they want to store it in the data warehouse. So which happens in most of the project. Okay, um, uh, so in that case, you need to follow the ETL approach.
okay. So,
Yeah.
and these things happen in data broker or data flow, this ETL process.
See, these are the process. Okay, don't relate this with the services. You can use any services. You can use BigQuery to do the ETL. You can use Dataproc to do the ETL. You can use Dataflow to do the ETL. Okay, so don't
Okay,
relate that to the GCP services. These are the concept, data engineering concept. GCP services are different. I will come to that. in from the next class we are going to study only the GCP services. These are the data
Okay.
engineering concept. Okay.